Hey everybody, welcome to the chain rule. This is Nicholas JMV. So the chain rule is a nice little rule that allows us to find the derivative of a function that is a composition of two or more functions. There's a couple ways I've seen this, and it's really similarly related to the power rule, okay? But I like the definition down here where it's the derivative of a composition is really the derivative of the outside, f, times the inside, times the derivative of the inside. So I wrote it. It's the derivative of the outside function times the inside times the derivative of the inside. And so that's what we're going to use here to help us. Okay, so let's get started on some examples right away. So our first example is cosine 4x cubed. Okay, so what you have to do is identify the inside and the outside. The inside function, 4x cubed, is inside cosine. So if I wanted to write this, if I just said y equals cosine of 4x cubed, okay? And I wanted to say dy, dx, take the derivative of both sides. So here's how we write it formally, okay? So I'm telling you I'm taking the derivative, okay? Now, what I'm going to do is take the derivative of the outside. So the derivative of the cosine function is negative sine. So I say negative sine, there's the derivative of the outside, times the inside, times the derivative of the inside. The derivative of 4x cubed is 12x squared. It's the power rule. So now I can simplify this. I'll bring the negative 12x squared to the left here, times sine of 4x cubed. And there is my derivative using the chain rule. So not terrible, okay? So that's our first example, and they get a little more complicated, so let's look at some more examples. Move this. Okay, here's our second example, the derivative of cosine cubed x. So this one's not bad either. Okay, what really is happening here is, let's just think about this as dx of, well, I'm going to rewrite this as cosine x cubed. So it's going to be a power rule. The inside function is cosine x, the outside is a cubic. It's a power rule. So the derivative would be 3 times the inside. The inside is cosine x. I'm using brackets here, it's grouping symbols. Remember, when you use a power rule, you subtract 1 off the power. So there is the outside, the derivative of the outside times the inside times the derivative of the inside, which is negative sine of x, which when I simplify I get negative 3 sine of x cosine squared x. I can bring the squared back in here. Okay, so there's our second answer. Okay. Now that's where they get a little more complicated. What is the derivative of the y equals the natural log of cosine of t? Well, first, the derivative of the natural log is this. Not terrible, but I don't have that here. I've got another function. So what I'm going to do is I'm going to let u equal cosine of t. That's going to be easier. So now I have y equals ln of u. And if I take the derivative of that, so dy dx equals d du of ln of u, I get 1 over u. But u is not just u. I have to take it times the derivative of u. Okay? Because u is no longer just a single thing. So it's more than one function. Or it's not just x, it's not linear. So the idea here is I'm going to have 1 over u times the derivative of the inside function, which cosine t becomes negative sine of t. Okay? And I have 1 over u. My u value was cosine, so I have 1 over cosine t times negative sine t. Well, that's just negative tangent of t. So there's my derivative. Okay? Last little example. Okay? The hardest one. What is the derivative of the natural log of sine of root x? Ooh, so look at this. There's a chain in here, right? One function in another. Then there's another chain on top of that. This is in ln. So let u equal sine of root x. Okay? So that means we're taking the derivative of ln of u, okay, which is going to be 1 over u times the inside. Now we have to times it by the derivative of the inside, which the inside, remember, the inside we called u prime, or u, so now we multiply by u prime. So we have 1 over u, which is sine root x, times the derivative of sine root x. So that's going to be 1, or that's going to be cosine root x times the derivative of the inside. Whoops. So the derivative of the inside, which is 1 over 2 root x. Okay? So now when I clean this up, I get cosine of root x over sine root x, okay, times 1 over 2 root x. And this simplifies into being cosine over sine is going to be cotangent, right? Cotangent root x. Leave the 2 over root x. And there we go. Okay, so that's our last example. It's our toughest example. So that's chain rules. So if you guys have any questions or comments, let me know. We'll see you next time.